All right, welcome to this explainer. Today, we're literally opening up the architect's blueprint for building a secure, highly capable, and fully autonomous AI system using OpenClaw. I mean, think of this as constructing your own digital company completely from the ground up. We're going to map out exactly how to build a super cost-effective setup without, risking your personal data or absolutely draining your wallet on API fees. To build this digital company outright, we're going to walk through 4 logical phases: the foundation, the workforce, security and maintenance, and finally, management and scaling. Okay, let's dive right into this. Phase 1, the foundation, hardware and models. So where is your AI actually going to live? It needs a physical home, right? Now, the official recommendation from OpenClaw is an always-on dedicated machine. You could grab a Mac Mini, which will run you anywhere from $500 to $1,000, or if you really want absolute peak performance, maybe a Mac Studio, which can go all the way up to $7,000. But look, if you don't want to make that kind of hefty investment upfront, there are absolutely cheaper, smarter ways to start. If you want to skip that huge upfront cost, you basically have 2 really great alternatives. First one is incredibly simple. Just grab an old laptop gathering dust that you probably already have lying around. As long as it has something like 16 gigs of RAM, you can just wipe it completely clean. It's totally free, it's highly secure because it's isolated completely locally, and honestly, it works wonderfully. Now, your other option is a VPS, or a virtual private server. This essentially means renting someone else's hardware for maybe $5 to $20 a month. But quick heads up here. A VPS is remote and really requires you to be comfortable running terminal commands. It's just far less convenient than plugging in an old MacBook. Because ultimately, your hardware dictates your brainpower, which means your strategy depends entirely on your system RAM. Sure, if you have an unlimited budget, you just run Claude Opus with a Sonnet fallback or use GPT-5 and call it a day. But let's look at some more realistic setups. If your machine has less than 32 gigs of RAM, like that old laptop we literally just talked about, you can effectively run the Minimax M2.5 model via API. It's highly capable and costs a fraction of those top-tier models. Now, if you have over 32 gigs of RAM, well, that unlocks the ability to use powerful local self-hosted models directly on the machine itself. Now that we've got our physical real estate all set up, let's move on to phase 2, the workforce, multi-agent systems. Now, what's really interesting about this slide is where the multi-agent system comes into play. If you give one single AI agent a massive project, it's honestly just like asking one human employee to do every single job in a massive corporation. They're going to get overwhelmed, they get confused, and the execution just completely suffers. By splitting complex projects among specialized AI bots, we radically improve execution and, as you'll see in just a second, we actually manage our token costs way better. So, let's meet a real-world multi-agent crew. We start with Inky, the primary manager who oversees the whole shebang. Then we have Blinky, the morning scout, who goes out and gathers news from places like Reddit and Hacker News. Next, Pinky steps in as the research analyst to do deep dives into those specific topics. Then Thinky takes all that research and produces the actual content scripts. After that, we've got Linky acting as the builder and coder for any software projects. And finally, Winky acts as the dedicated system health monitor. See, everyone has a very specific job. And beyond simply avoiding all that confusion, this split workforce drastically reduces your token budget. Think about it. If you rely on a single agent, you are forcing one incredibly expensive top-tier model to do absolutely everything, from basic text formatting all the way to complex coding. That can literally cost hundreds of dollars over time. But with the multi-agent system, you unlock highly cost-effective model routing. You're basically matching the right brain to the exact right task. To put that into perspective, let's look at how this split workforce actually handles that routing. Inky, the manager, uses the expensive Claude Opus model because, obviously, management requires some really high-level reasoning. But take a look at Linky, our coder. Linky uses Opus for the initial planning phase, but then seamlessly switches over to Qwen Coder 8B, which is a free open-source local model to write the actual code. Meanwhile, Winky, who literally just does routine security audits, runs entirely on a tiny, completely free local Mistral 3B model. You just aren't paying premium token prices for routine, everyday tasks. With our workforce humming along nicely, we arrive at phase 3, security and isolation, protecting your assets. Just like you wouldn't leave your physical office doors wide open overnight, there is one absolutely critical safety rule we have to establish right now. Do not install OpenClaw on your personal, daily use computer. Seriously. Why? Because OpenClaw, by its very design, has access to the files on the machine it's running on. If you drop it onto the computer that holds your personal emails, your passwords, and your private banking data, you are basically inviting an absolute disaster if the agent makes a mistake or goes a little off the rails. So, to keep your setup completely secure and stable, you've got to follow a strict daily maintenance routine. First, as we just hammered home, isolate the hardware entirely. Give it its very own machine. Second, schedule the built-in OpenClaw security audit to run twice a day. Third, pipe those audit findings directly into a Discord alert channel so you are immediately notified if there are any critical vulnerabilities. And fourth, put your entire OpenClaw directory on GitHub version control. That way, if an agent ever does go rogue or accidentally corrupts a file, you can literally just revert back to an older version so you never lose your progress. And this brilliantly illustrates why we need Phase 4. Management and scaling, automation and Claude code. There is a pretty harsh reality to working with AI that we need to address. Code is stupid, but it's stable. Large language models are absolutely amazing, for sure, but they are inherently unpredictable. If you rely entirely on text prompts to run your entire pipeline every single day, eventually a point of failure is going to happen. The text prompt will get misinterpreted, and the whole chain just breaks. So to scale properly, we eventually have to turn our successful text-based workflows into hard, rigid code. And that brings us to an absolutely crucial tool for our digital architect, the cron job. Now, for the non-developers tuning in, don't worry. A cron job is basically just a time-based scheduling service built right into your operating system. It automatically runs repetitive scripts. So instead of manually chaining together fragile text prompts and literally asking your AI to do its daily tasks every single morning, a cron job just runs a stable piece of code automatically at the exact same time every single day. So here is your definitive playbook for scaling this up. Step 1, build a really cool, highly effective workflow using text prompts with your agents. Step 2, run it for a while until you identify those natural points of failure we talked about. Step 3, take the parts of the prompt that don't actually need AI generation and translate them into stable, hard code. And finally, Step 4, automate that new coded workflow daily using cron jobs. This is what guarantees that long-term stability you're looking for. Now, as you get more advanced with this, you can actually optimize your token usage even further by combining OpenClaw with Claude Code. The trick is to use OpenClaw for what it's best at, doing daily logging, maintaining your long-term memory markdown files, and tracking local file changes. But when you hit a wall, you leverage Claude Code for the heavy debugging and building out major complex projects. Because if you already have an existing Mac subscription, running Claude Code just uses that subscription, which basically saves your precious OpenClaw token budget for all those other daily tasks. It's just a brilliant synergy. All right, we've laid out the entire blueprint for you. You've seen exactly how to secure the hardware, hire a specialized multi-agent crew, lock down your security, and automate the daily grind. So the final question is, will you architect your own secure autonomous workforce, or are you just going to continue paying for repetitive digital labor with your own time? Grab a laptop, wipe it clean, and start building. Thanks so much for joining me on this explainer, and I'll catch you guys next time.